Oh, let's get started. Uh, Hi, and welcome to today's poster session. My name is Lana, and I'm going to briefly walk you through the posters of this session. Then you can chat with the authors directly in the corresponding rooms. Now, our first poster today is a collaboration between the Chinese Academy of Sciences and the Southern University of Science and Technology. It proposes a high-throughput three-dimensional systolic accelerator for NAS-optimized neural networks. The 3D systolic data flow approach, with the use of multi-bit with MAC units, allows both the processing time and logic resource consumptions to be reduced compared to a classic non-stationary systolic array. The accelerator can achieve peak throughput of the convolutional layer as high as 2,700. Our second paper is from UCLA. It proposes to model the HLS tool with a graph neural network model to estimate the quality of the HLS design points and to reduce the time needed for design space exploration. The experiments done by this work demonstrate that the approach can estimate the quality of design in milliseconds with high accuracy and results in an average speedup of 55 times for optimizing the design compared to previous state-of-the-art work. Our next poster is a collaboration between Boston University and AMD. It proposes an efficient implementation of an EC-DSA signature verification on an FPGA. And the goal is to improve performance of the Hyperledger fabric. This is a commonly used permission blockchain. The authors explore several optimizations, including those related to arithmetic units and moving some operations to pre-computation blocks. The Hyperlogic Fabric specific engine can perform verification in 300 microseconds and lead to a very high throughput of signature verifications per second. Our next poster is from the University of Southern California and the US Army Research Lab. It studies homomorphic encryption, which is promising for performing secure inference because the encrypted data is sent from the user to the cloud server and back without being decrypted. So the authors propose an integrated design for end-to-end acceleration of homomorphic encrypted CNN inference, and they develop a parameterized performance model to evaluate the design latency and resource consumption. The proposed FPGA implementation achieves over 4 times performance improvement over the software baseline. Our next poster is from two Greek institutions, University of Thessaly and the Foundation for Research and Technology, Hellas. It studies visual simultaneous localization and mapping. This is the process of mapping the robot's environment using an optical sensor, while at the same time determining the pose of the robot with respect to that map. So the authors present a graph optimization module, which is based on RGB features, as an extension of the Kinect Fusion pipeline to help recover the robot's pose. The author shows that different optimizations and parameter tuning can provide a speed up of up to 15 times compared to a classic FPGA implementation. Just a sec. Sorry, I have some problem. Okay, our next poster is from Brown University and the University of Michigan. It presents an FPGA accelerator for non-parametric belief propagation for robot manipulation. NBP algorithms have wide applications in robotics because the robust performance that they can achieve. But they are very computationally intensive, which prevents them from being applied in real-time systems. So the authors designed a novel accelerator architecture that can process any probabilistic graph model, and they achieve significant runtime and energy improvement compared to a GPU implementation. Our next work is from the University of Central Florida. It introduces HMP, which is a hardware-friendly bonsai Merkle tree algorithm that is used for data authentication in secure systems. The authors propose a BMT controller with a data flow architecture and speculative buffers that allow multiple parallel authentications on flight, and this was not possible with prior solutions. The proposed system enables up to 7-time improvements in bandwidth, while also exhibiting a significant reduction in latency over the baseline. Next, we have a work from the University of Texas, Austin, which proposes converting block rounds on FPGAs into new blocks that are called math rounds. Math rounds enable compute and memory capabilities by adding configurable processing elements near the sense amplifiers in the block round. The dual port nature of the block round is exploited to read 2 operands at the same time. The authors observe speedups of up to 2.2 times across multiple benchmarks, and all of this at a minor area overhead of around 5% at the chip level. And our final poster is from Columbia University. It describes a synthesized hardware garbage collector for FPGA accelerators. The collector exploits rapid hardware synchronization to fill idle memory slots, and it runs concurrently with the accelerator with little or no impact on performance. Okay, so this was the quick intro. I encourage you now all to visit the poster room and to talk to the authors and ask them questions about their work. You can find the poster rooms by going on the schedule and clicking on find out more for the poster session. You will see the links to the individual rooms for the different posters. Okay, that's all from me, and enjoy the rest of the conference.